Hello everyone, in this video we're going to be solving a geometry puzzle. 3 circles are inscribed in a unit hexagon as shown. Find the radius of the red circle. So we have 3 circles, 2 of them are congruent, the green ones, and the red one is a bigger circle, and we're going to find the radius of that one. Alright, at this point, if you want, pause the video and try this problem. Okay, so what are we going to do? We're going to be making some connections as always. So let me start by dropping a perpendicular here. A perpendicular line that goes through the center of the red circle. So it's going to look like this. Okay. And then obviously from symmetry it's going to go through the middle. So that means I can just connect the centers here, which is going to help us. And then we're going to make 2 right triangles here. I don't really have to deal with both of them because they're identical, but you know, from symmetry we basically have that they're equal or congruent. All right, so we need to find the radius of the red circle, but in order to do that we need to find the radius of the green circle first. Okay, I mean we can find them at the same time, but I'm just gonna find the radius of the green circle because that's not too hard to find. All right, if you go ahead and drop more perpendiculars and then make more connections, obviously here we can just go ahead and, you know, draw these 2 segments, because basically what we're trying to do here is we're drawing 2 tangents from a point outside a circle, and we know that they're congruent and we get 2 congruent triangles, so we're going to take advantage of that fact. Okay, so this is one and this is another one. So, all right, so these are perpendicular, 90-degree angles. And then obviously I'm going to draw this one as well, which is the angular bisector here. Awesome. Okay, so we're ready to solve for the radius of the green circle. Let's call that, I don't know, x maybe. Okay, let's call that x. And then I'm going to call this r. Awesome. So let's see what we get. I know that this is a unit hexagon. It's a regular hexagon. So these are going to be 60 degrees, right? So we have the 30, 60, 90 triangle, which means that the longer leg is √3 times the shorter leg, but we're given the longer leg, so we have to divide by √3. That's going to give us x divided by √3. If you rationalize, you'll get √3x over 3. So how should I write? I was just thinking about that. Okay, and the same thing here. All right, awesome. Now, those lengths are going to be helpful, and then this is x, this is x, this is x, and this is x. So this is the critical part. How do you find the radius? Well, we do know that this is a unit hexagon, so each side length is 1. So I can write √3x over 3 multiplied by 2 plus 2x is equal to 1. So let's go ahead and solve for x here. What I can do is I can take out the x. Then I should be getting 2 √3 over 3 plus 2. And that product is equal to 1. Let's make a common denominator. X times 6 plus 2 √3. And 6 is greater. That's why I wanted to write that first. And that's equal to 1. And from here, if you solve for x, it's going to be 3 over 6 plus 2 √3. If you rationalize the denominator, multiply by the conjugate, 6 minus 2 √3, and then it's going to give you, let's see what we have, 3 times the quantity, 6 minus, by the way, I can pull out a 2 here. I think that will be helpful. Factor out a 2 here. And that should give me a 6 times 3 minus √3 divided by these 2. When multiply is going to give us 36 minus 12, which is 24. Awesome. Then what I can do is I can cross cancel. 6 goes into 24 4 times. And now I can go ahead and write x here. X is equal to 3 minus √3 over 4. We're going to use this to find the radius of the red circle. All right, let's change colors here and let's see how we can use it. Awesome. So now I got x, which is the radius of the green circle. Let's go ahead and write an equation to find the radius of the red circle. How do we do that? Okay, so this is x and this is r. So we have a right triangle here whose hypotenuse is x plus r and whose base is x. So let's call the height h, and let's go ahead and write h in terms of x and r. So by Pythagorean theorem, we're going to get x squared plus h squared is equal to the hypotenuse. And if you remember, the hypotenuse is x plus r, right? X plus r squared. So if you expand this, you're going to get the value of h here. X squared plus h squared is equal to x squared plus 2xr plus r squared. X squared cancels out. We end up with h squared. I do need to take the square root, and I'll be getting this one. Okay, so here's the thing. I do know the value of x, right? So what I can do here is I can just plug it in. But let's just wait until the end, because if you just plug it in right now, you're going to have to deal with some radicals inside radicals. Yeah, it's not going to be the best experience. So what am I going to do next? Well, I know that this is x, kind of like the height of this rectangle here. So this is r. Now consider the vertical segment that runs from this point to that point. We can find the length of that perpendicular segment. Why? Because if you connect these 2 points on the hexagon, you're going to notice that these 2 lines are parallel and they're congruent. And the length of that line can actually be found because we're dealing with 30, 60, 90 triangles here. So this is at 30 degrees, this is 60, this is 60, and this is 30. And as you know, this is a unit hexagon. So the hypotenuse here is 1, meaning that the longer leg is going to be, well, I can go off of this, like this is going to be 1/2. And if you multiply by root 3, this is going to be root 3 over 2. If you double that, you get root 3. So keep a long story short, the height is going to be root 3. Okay? Which is the sum of these pieces. So what am I adding? R plus h plus x, right? R plus h plus x is equal to root 3. And I do know the value of x. So I can just go ahead and plug that in and find the value of x from here, or r from here. We already have the x. Okay, awesome. So the next level is going to be solving for this system. We have 3 variables, but you know, x is known, and also r, we have h in terms of x and r, but x is given, so h is written in terms of r, and we do have another equation that relates to h and r, so on and so forth. Okay, so from the second equation, if I isolate r plus h, I'll be getting root 3 minus x, and x is given as 3 minus root 3 over 4. So let's go ahead and simplify this. R plus h is going to be 4 root 3 minus 3 plus, so it's going to give us 7 root 3 minus 3 over 4. Okay, so this is going to be the value of r plus h, right? Hopefully we didn't make any mistakes here. 4 root 3 plus root 3. Okay, we did. Okay, awesome. Great. Beautiful. So it's not 7 root 3 because it is 4 root 3 plus root 3. So that will be 5 root 3. There we go. Okay. All right. So this is the value of r plus h. And then I know that h is equal to that. So what can I do here is, one of the things I can do is I can try to isolate h from here. And then I can just go ahead and set it equal to the radical expression. Let's see what this gives us. So this is h, right? Minus r, of course. And then it's also equal to this one. So now here I can just go ahead and plug in the value of r. And r is, I mean x. X is equal to 3 minus root 3 over 4. Let's copy that here. So now what I can do is I can use this equation. 2x is going to be 3 minus root 3 over 2, because it's going to cross cancel, times r, right? Plus r squared. Beautiful. We don't know what r squared is at this point, but we're going to find out. Okay, awesome. So what we're going to do here is we're going to square both sides. The nice thing is, though, we have r squared and we'll get r squared. Nice. So, and if I square both sides at this point, basically, I can just go ahead and write h squared is equal to this, and it's equal to that. I guess I could just leave the h squared alone and then go from there. Same thing. So I should be getting 5 root 3 minus, I don't know, I'm writing 4, minus 3 over 4 squared minus 2r times 5 root 3 minus 3 over 4 plus r squared is equal to 3 minus root 3 over 2 times r plus r squared. Awesome. Now r squared cancels out, right? So we end up with a nicer expression. More importantly, we get a linear expression. So 2 goes into 4, that becomes a 2. Now I can just go ahead and add those two terms, and at the same time I can square these. That's a quotient. So if I square the top, which I square the 5 root 3, which is going to give me 25 times 3, that's at 75, right? Minus 3 times 5 is 15, double that, 30 root 3 plus 9 over 4 squared, which is 16. And then on the right hand side, I should be getting 3 minus root 3 over 2 times r plus 5 root 3 minus 3 over 2 r, because we have an r here. And that's it. So we're pretty close, right? Okay. What am I supposed to do next? Simplify as much as I can. Let's go ahead and write this on the left hand side by adding the numerators. I should be getting 4 root 3. By the way, the negative 3 and the positive 3 cancel out, so that's nice. 4 root 3 over 2 r is equal to 75 plus 9 is 84 minus 30 root 3 over 16. Of course, I can simplify this more. I can just go ahead and cross cancel like this. That's going to give me 2 root 3. And then what I need to do is just multiply both sides by 1 over 2 root 3, which is the reciprocal. So r is going to equal 84 minus 30 root 3 divided by 16. I'm going to simplify at the end. 1 over 2 root 3. Okay. Now, what I can do is r is going to, from here, r is going to equal 84 minus 30 root 3 divided by 32 root 3. Awesome. So what I need to do now is simplify as much as I can, at the same time rationalizing the denominator. Let's do that first. Okay. Let's multiply root 3 and root 3. That's not division, by the way. We're going to back up a little bit to fix this mess. Okay, awesome. So now this is going to look like root 3 over root 3. And when I distribute, it's going to look like what? 84 root 3, obviously greater than 90, right? Minus 90. And 32 times 3 is going to be 96. Awesome. Now we need to find a common factor. 84 is divisible by 7 and 12. It's 7 times 12, so therefore it's divisible by 3. 90 is divisible by 3 as well. It's also divisible by 6. I think these numbers are all divisible by 6, but I don't think they're divisible by 12 because 90 doesn't divide by 12. Okay, cool. So the greatest common factor is 6 then. I'm going to go ahead and multiply. I mean, you know what I'm talking about, right? I'm going to divide everything by 6. That's going to give me 14 root 3 minus 15 divided by 16. And that's going to be the radius of the, what? R is going to be the radius of the red circle. That's what we've been looking for. We found X, we had to find it. But now R is the radius of the red circle, R for red. And R is equal to 14 root 3 minus 15 divided by 16. All right, that's our answer. Thank you for watching. I hope you enjoyed the puzzle. Don't forget to comment, like, and subscribe. I'll see you in the next video. Take care. Bye-bye.